Hello, my name is Matt, and today I will be showing you how to solve number 5 in the Inclined Planes and Forces worksheet. So, in this problem, we want to find how fast the box will be traveling at the bottom of the ramp. And in this problem, we see that the ramp is at a 36-degree angle. The box is 90 kilograms, and so the box starts at rest, and after traveling down the ramp for 10 seconds, it reaches the bottom of the ramp. The coefficient of kinetic friction is 0.25. So, in order to solve this problem, we need to break it up into two steps. First, we need to find the net force, and then we need to use the net force and plug that into the equation F equals ma, and manipulate for A to find the acceleration. And then using the acceleration, we use some of our equations from the first unit of kinematics, and we solve for velocity, the final answer will be how fast the box is traveling at the end of the ramp. So first step, we need to find the net force. So first we draw a force body diagram which breaks down all the forces acting upon the box. So we have the normal force, which is pushing up which is the force pushing up through the box in the right direction. And then we have the force of friction, which is pushing in the opposite direction. And then we have the force of gravity, which is pulling straight down on the box. So in order to find F net, we know that the normal force and the force of gravity in the x direction are equal to 0. So another name for the force of gravity in the x direction is F parallel. So we know F parallel equals 0, so because the object is at rest. So now we need to find the force of gravity in the y direction, which will give us the F net. So what we do here is we find that the object is 90 kilograms, and the acceleration is 9.81. And then because of the incline, we have to multiply that by sine of 36 degrees. And then we need to subtract the frictional force, which is cosine 36 degrees times 90 kilograms times 9.81, and then times the coefficient of friction, which is 0.25. Now, when we do the calculations, we multiply everything, subtract everything, we find that the net force is 340.385 newtons. So after this, we need to go into our second step, which is to find the acceleration. So what we do here is we use Newton's second law, F equals ma, and since we know the weight and we know the force, we can then take the 340.385 newtons and divide by the mass, which is 90 kilograms, and give us the acceleration. So you can see right here that after doing that computation, we get A equals 3.782 meters per second squared. Now from that point, we go on to the third step, and we use the equation we learned in the kinematics unit, which is velocity equals acceleration times time plus the initial velocity. But since the box is at rest, there's no initial velocity. And then we can just say velocity equals acceleration times time, and the acceleration is 3.782. And from the problem, it says that the object travels down the ramp for 10 seconds. So we multiply 3.782, the acceleration, times the time. And then the final velocity is 37.82 meters per second. So, in conclusion, the box is traveling at 37.82 meters per second at the end of the ramp. Alright, I hope that was informative, and I hope that you can use this to your benefit. Alright, thank you.